Welcome to Module 4, Lesson 9, Data Inferences. In Level 1, we're going to be looking at the margin of error. The margin of error is a statistic that measures the uncertainty of a potential error in survey or poll results due to sampling, right? When we take a survey, it might not be 100% accurate to the entire population that we're talking about. So we're going to take a look at the margin of error and how we can work with it and how we can use it to make predictions. So some key concepts about the margin of error: sampling versus population. A sample is just a subset of a population used to gather data and make predictions. The margin of error accounts for the fact that the sample might not be perfectly representative of the population. The confidence interval. The margin of error is often paired with a confidence interval. That's usually expressed as a percentage range. And the formula that you need to know to calculate the confidence interval is the sample statistic plus or minus the margin of error, right? So we'll need to add the margin of error and subtract the margin of error. Interpreting the margin of error. A larger margin of error means less precision in the estimate, and a smaller margin of error means more precision in the estimate and that the estimate is more accurate. Some factors that affect the margin of error is the sample size. Larger samples lead to smaller margins of error, right? And that makes sense because a larger sample size is going to be closer to the actual population. More variability increases the margin of error, and higher confidence levels lead to a larger margin of error. So let's look at making some predictions. If 70% of a sample of 1,000 people prefer chocolate with a margin of error of plus or minus 2%, predict what is the range of possible percentages of the people who prefer chocolate in the entire population. So we're going to have to take our 70% and add and subtract the 2%, the margin of error, to find this range. So we'll do 70% minus 2%, that's 68%. And 70% plus 2%, that's 72%. So our range is from 68% to 72%. Please pause this video and work on the Lesson 9, Level 1 problems in the workbook. In Level 2, we'll take a look at the sample rate. The sample rate is a proportion of individuals or items in a sample that exhibit a specific characteristic. On the SAT, you'll need to use sample rates to make predictions or draw conclusions about a larger population. Some key concepts about the sample rate. So first, you'll need to know the sample rate formula. The sample rate is equal to the number of favorable outcomes in a sample divided by the total sample size. And then you need to know the population prediction formula, which is the sample rate times the total population size. So usually in questions, you'll need to use both formulas, first the sample rate formula and then the population prediction formula. Some assumptions are that the sample is representative of the population and that there's no bias in the data collection. And sample rate is a percentage. The sample rate is often expressed as a percentage, making it easier to make predictions about a population. Steps to use for sample rate predictions. First, find the sample rate. So use that formula in the previous slide to find the sample rate. Then scale the population, right? That was the second formula. You'll multiply the sample rate by the total population. And then check for reasonableness. Ensure that the prediction aligns with the context of the problem. So let's take a look at an example. In a random sample of 50 students, 12 prefer online learning. If the school has 800 students, how many are predicted to prefer online learning? So first, let's use the sample rate formula. The number of favorable outcomes in a sample divided by the total sample size. So that would be 12 over 50, right? 12 prefer online learning out of the 50 students that were sampled. So 12 divided by 50 is 0.24, and that's 24%. Now we'll use the predicted population outcome. So we'll multiply the sample rate that we just found by the total population size. So that would be 0.24 times 800, which is 192. So it's predicted that 192 students in the school prefer online learning. Please pause this video and work on the Lesson 9 Level 2 problems in the workbook. In Level 3, we'll look at an advanced problem. This requires you to read the question carefully and make sure that you answer exactly what the question's asking you. A poll shows that 35 out of 200 respondents support a new law. The population size is 5,000. Predict the number of people in the population that do not support the new law. So first, let's find the sample rate. We'll use our sample rate formula, and we'll divide 35 by 200, and we get 0.175, which is 17.5%. Now we'll figure out the predicted population outcome by using the formula. We'll multiply the sample rate that we just found by the total population size. So we multiply 0.175 by 5,000, and we get 875. Now, many students will stop here and say that 875 is your answer. And for multiple choice questions, the SAT will definitely put 875 as one of the choices. But the question is not asking the predicted number of people in the population that do support the law, right? 875 represents the number of people predicted to support the law. They're asking how many people are predicted to not support the law, right? This question here, predict the number of people in the population that do not support the new law. So that means we have to take our population of 5,000 and subtract 875. And from that, we get 4,125. So it's predicted that 4,125 people in the population do not support the new law. Please pause this video and work on the Lesson 9 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please move on to the next video for Lesson 10.